In 2012, a well-known e-commerce platform pushed a routine database update to production on a Friday afternoon. The change was small. One column in the products table was being renamed from price to unit price to be consistent with a new naming convention across the codebase. The developer tested it. The staging environment passed. The rename took less than a second to execute. Within 4 minutes, the entire checkout flow was broken. No products could be added to a cart. No orders could be placed. The site was effectively frozen for anyone trying to buy something. The rollback took 40 minutes. The lost revenue during that window ran into 6 figures. The column rename was a single line of SQL. It touched every part of the application that had ever used the word price. The developer had updated the application code. He had updated the main product service. He had not updated the cart service, the recommendation engine, the search index, the analytics pipeline, or the third-party pricing API that 2 other teams depended on. He didn't know those dependencies existed. Nobody had written them down. This is what a schema change feels like in a system that wasn't designed for change. And it happens, in some form, in almost every production database that has lived long enough to accumulate dependencies nobody fully understands. Most people think of a database schema as a technical detail, a list of tables, columns, and types. Background infrastructure, the thing you set up at the start and don't think about again. That framing is wrong, and it's expensive. A schema is a contract. Every column name, every table name, every relationship between tables is a promise that the database makes to every piece of code that reads from it. Your application reads price from the products table. That read is a handshake, the database promising that price will be there, that it will contain a number, that it will mean what it has always meant. When you change the schema, you break the contract, not just with your own code, with every piece of code that was ever written against it, including the code you've forgotten about, including the code written by a team that never told you they were using your table, including the code in a third-party integration that reads your database directly and has no way of knowing you renamed a column last Friday. The rename didn't break the database. The database was perfectly happy. It stored unit price correctly, returned values correctly, violated no rules. What broke was everything outside the database that was still asking for something that no longer existed. Let's understand why this is so much harder than it sounds. Imagine a city that decides to rename a street. Maple Street becomes Oak Avenue. The street is the same, the buildings are the same, the route is the same. But every address on that street is now wrong. Every letter in transit to a Maple Street address won't arrive. Every GPS system that hasn't updated will give wrong directions. Every business card, every website, every contract that lists a Maple Street address is now pointing to a location the city no longer recognizes by that name. The city made one change. The consequences propagated everywhere the old name was written, and the city had no way of knowing everywhere the old name was written. A database column is the same. When it was created, its name was written into application code, then into test files, then into API response schemas, then into documentation, then into a third-party integration someone set up without telling you, then into an analytics dashboard that queries the database directly, then into a data pipeline that runs every night and nobody monitors closely, then into a spreadsheet someone built 3 years ago that connects to the database and which 17 people in the finance team use every Monday morning. None of these places are inside the database. The database has no record of them. When you rename the column, none of them know. And this is what makes schema changes dangerous in a way that most other changes are not. A bug in application code affects the users of that application. A bug in a database schema affects every system that has ever touched that database. The blast radius is invisible until something breaks. Now let's talk about something more subtle. Renaming a column is the obvious case, but schema changes that break systems aren't always renames. Changing a column's data type is a schema change. A column that stored prices as integers with values in pence to avoid decimals gets changed to store floats to allow fractional currency. The database accepts the change. Every service that was dividing the integer value by 100 to display it correctly now gets a float and divides it again. Prices display as 1/100th of what they should be. No errors, just wrong numbers that look almost right. Removing a column is a schema change. A column called legacy ID that hasn't been updated in 2 years gets dropped because it appears unused. The analytics pipeline that runs at 3 a.m. every night was using it to join 2 tables. The pipeline fails silently. The data warehouse misses a day. Nobody notices for a week because the dashboard shows the last known values, not an error. Adding a not null constraint to an existing column is a schema change. The column currently has 40,000 rows with null values in it. Adding the constraint fails, but in some databases, under some conditions, it can lock the table while it validates every existing row, blocking every read and write to that table for minutes or hours on a system that serves thousands of requests per second. The schema change wasn't wrong, the timing and the method were. Even adding a new column can be a schema change that breaks things. An ORM, a layer of code that maps database columns to application objects, sometimes expects its object definition to exactly match the table definition. Add a column the ORM doesn't know about, and some ORMs throw an error, not because the new column is wrong, but because the contract they expected no longer matches what the database is offering. The schema is a contract. Every change renegotiates the contract, and contracts cannot be renegotiated unilaterally without notifying every party who signed them. So how do you change a schema safely? The first principle is to expand before you contract. When you rename a column, don't rename it. Add the new column alongside the old one. Write to both columns simultaneously. Gradually migrate every consumer to read from the new column. Once nothing is reading the old column anymore, drop it. This process takes longer. It requires discipline. It means your table has a redundant column for days or weeks. But it means that nothing breaks. Every consumer transitions at its own pace. The old column continues to keep its promise until the last piece of code that depended on it has moved on. This technique is called an expand contract migration, and it is the standard approach in any system where downtime is not acceptable. The second principle is to know your dependencies before you touch anything. Before any schema change, search every codebase, every service, every integration for the column name you're about to change. Not just the repositories you own. Ask other teams. Check third-party documentation. Look at the analytics queries. Check the data pipelines. Find the 17 people in finance with the spreadsheet. This sounds extreme. It is proportionate. A schema change has a blast radius proportional to how widely the old name was used. The only way to contain the blast is to know the radius before you detonate. The third principle is to version your schema changes like you version your code. Every change to the schema should be a documented, reviewed, intentional migration, not a quick command run at the terminal on a Friday afternoon. Schema migrations should go through the same review process as application code. They should be tested in staging with production-like data. They should be deployed in a controlled window with a rollback plan. The fourth principle is to treat the database as a shared resource, not a private one. If other teams or services read your tables, those tables are a public API. Changing them without notice is the same as changing a public API without notice. You wouldn't remove an API endpoint without telling the teams that depend on it. A column is an endpoint. Its name is the address. Its type is the contract. And the moment you change either of those things without coordination, you have broken a promise to everyone who was relying on it. A database schema feels static. It was built once, a long time ago, by someone who understood the system completely. It doesn't seem like the kind of thing that needs careful change management, but a schema that has been in production for years is one of the most load-bearing structures in your entire organization. Every report, every integration, every API, every analytics dashboard, every data pipeline, every third-party connection is resting its weight on those column names. The older the schema, the more weight it carries. The more weight it carries, the more carefully you must move it. Because the thing that brings down a production app is rarely the ambitious change nobody wanted to make. It's the small change everyone assumed was safe. The rename that took 1 second to type. The column that looked unused. The constraint that seemed obvious. The change was simple, the dependencies weren't. And nobody had written them down.